Okay, this is presentation 9.1 and it's on the contaminated remediation and monitoring and aftercare. So the last two phases of the contaminated site management cycle. The content of this session, the table, I will again start with the content of table of model 8. Then I will have some details about site remediation objective, the task and the strategies. Then we discuss project risk and project risk management goals, risk management principles and origin of risks. Then the 5 hallmarks of project management are discussed, the process of project risk management, health and safety aspects of the remediation. And then we come to phase 5, monitoring and aftercare. Then I give you a slide with an infographic with the task and deliverables of all the phases, and then I end with a flow diagram of phase 4 and phase 5. So this model 8 covers phase 4 and phase 5. Table of content. After introduction, one chapter discusses phase 4, the remediation itself, and the remediation itself is called remediation management. After introduction, we discuss the tendering, the detail design, what should be the objective of detail design and who's doing it and who is taking the responsibility. Remediation management, then the task of the management of the operation, then remediation, evaluation and closure, and the reporting. The reporting of the remediation project is being discussed in the last section. Then the section number 3 of model number 8. After introduction, we discussed the monitoring, the sampling of groundwater, sampling of air, the aftercare, so what should be taken care of, the organization, and again I close with the monitoring and the reporting of this phase. This model also gives a list of references that can be consulted if you need more information. Okay. Phase 4, remediation management objectives. It's actually very clear. Eliminate, reduce, contain the environmental risk. These are the objectives and of a remediation. And then you can divide it in the source, and you can remove, pack, transport, and destruct POPs. Here, if you have a stockpile of POPs, the objective is source removal. Remove by ex situ or in situ remediation of contaminated soil and groundwater. And soil is when it's pumped soil is excavation. Ex situ for water is pump and treat. And then of course the in situ remediation, sparging, bioremediation, chemical oxidation. Then you can contain your source is by in situ isolation, mobilization and stabilization of contaminated soil. You inject, for instance, cement bentonite to make an inert portion in the soil that's contaminated. That means immobilization. But ex situ containment is, for instance, landfilling, and immobilization, stabilization off-site. So you take away the soil, you mix it with cement bentonite, and you make a depot to contain this contaminated soil. As I earlier said, this is done often with acid tar. Then the other objective, source receptor pathways, remove. Again, actually the same practice, ex situ or in situ remediation of soil and groundwater. Cut off the pathway, control soil erosion. Cut off means you make sure that the migration is not anymore taking place. Restore the vegetation cover, provide that will reduce the risk of erosion, and groundwater pump and treat. You also cut off the pathway, you pump in your source receptor pathway, you pump away the groundwater so that migration of contaminants is not anymore taking place. But you can also contain the source receptor pathway, isolation, again the same, immobilization, stabilization, and containment can also be done by monitoring natural attenuation, meaning that you make use of the natural processes in groundwater and you establish your objectives, but you have to monitor if you're right. And of course, it is in such a way that monitoring natural attenuation is to protect the receptors. So if you have a water well downstream, you calculate if it is possible that the contamination is reaching the well, and if it's not because of the natural attenuation, you monitor, but then you make use of the natural attenuation. So I will just make a short summary of this slide. So the objective of remediation is to eliminate, reduce or contain the source receptor pathways, and the receptors are protected by raise awareness, for instance fence the site, forbid people to enter the site, and restrict land use. You're not anymore allowed to farm, you're not anymore to construct houses. So these are the objectives of a remediation. summarized, of course. And environmental risks, we talk about human health risk, ecological risk, and contaminant migration risk. The task of the remediation are design the remediation campaign. You have to make a design, then select the tendering method. You have different types of tendering. Item-based, that's simple. So many tons have to be excavated, so many cubic meters have to be pump and treat. And then item-based, you have unit prices for the item, and you just calculate the number of tons to be exported, and then it's paid based on unit price. Item-based contracts, then you have, as the contracting party, you have the responsibility of the design. You have lump sum contracts. So you say, okay, this is what you have to do, give me one price. And you say, okay, it's plus of my, and then you also define the boundaries. In most cases, it's plus or minus 10% of the given volume. If it's above and below, you restart negotiations. But lump sum is often done to get rid of the responsibilities of the contracting party to a certain extent. Then we have the last one, design and construct. And then you share with the contractors that want to do a bid. You share all the information and you ask them to make a detailed design, and based on the detailed design they can give their price, but then all the responsibility are with the contractor. And this is often done for large complex sites and when the contracting party has not much experience. So please, if you tender a remediation campaign, be aware that you can have different ways of contracting, and the different way of contracting shift the responsibility. Item-based responsibility are with you. Lump sum, the contractor's responsibility are shared. Design and construct, the responsibility are with the contractor. Yeah. To tender, you have to make a long list of the contractors that you would like to invite. You publish the expression of interest to the long list members. On the expression of interest, you pre-select bidders, and this pre-selection gives you the shortlist. Then you publish the terms of reference to the selected groups, to the shortlist members. You send out a request for proposal. Okay, please, you are selected. Are you still willing to give me an offer? And in this request for proposal, you make sure that it is based on the selected tendering method, item-based, lump sum, or design and construct. Then you get the request for proposal from the bidders, you evaluate it, but you do not only look at the financial, but also technical. And you make a scoring for financial and a scoring for technical. And please don't take only the cheapest one. Make your decision for the selected bidder based on technical evaluation and financial evaluation. And nowadays, the technical score should be dominant above the financial score. But there are several formulas to do that, and most likely you have also in your country these regulations. But don't look only at the finance, but also look at the quality of the bidder and the experience of the bidder. Contract the most beneficial proposal. Finally, detailed design remediation campaign, contract negotiation, evaluate the final offer, and sign the contract. So these are the steps to be taken if you have selected one. Then the remediation itself, the contractor will mobilize, remediate, so implement the remedial action in conformity with the terms of reference given in the request for proposal, and then the demobilization. And this process has to be managed and monitoring on site during the whole operation. So there should be an independent organization that monitors the process. Independent means not someone from the contractor, but who is well aware of the processes and manage and monitor these on-site activities, and to have the authority to stop the process when it's, for instance, not in conformity with the request for proposal, when unsafe situations happen, and so on. So there are three parties involved in the remediation. That's you as the commissioner, that's the bidder that won the contract, and that's the monitoring organization, which is independent from you and from the contractor. The approach of remediation management is risk-based approach and phased implementation. Implement emergency measures for urgent risk directly or as soon as possible. Eliminate direct risk on the short term, remediate potential risk on the mid-term, contain and monitoring latent risk on the long term. And your work plan should be dynamic. So have some extra time when things are not as they are supposed to be or are different than assumed. Have at least 10% of financial resources for unforeseen and have a fallback scenario. Make sure that if things do not work out, that you have a fallback scenario. Actually, here this is a slide with the same information, but now with a bit more information. So remediation or risk reduction measures are divided in short-term, addressing direct risk, and then this is divided in, okay. So the short-term risk reduction measures addressing direct risk, and they can be divided in emergency measures that should be implemented as soon as possible. Emergency measures is, for instance, forbidding land use, putting a fence, putting signs, inform the people around, raise the awareness of the school kids not to enter. And then other short-term measures are removing or treating the source area. Mid-term measures addressing the remaining potential risk, long-term addressing the remaining latent risks. And here is the strategy. So phase 4, the remediation itself, is often short and mid-term measures. Short-term measures, after we have finished your remedial assessment, phase 3, and the R emergency or the direct risk, and they should be, let's say, addressed as soon as possible. And the other short-term measures in the first year. Then you have the mid-term measures, remediation, and so on, 1 to 5 years. And then the long-term, and then we are already in phase 5 for addressing the remaining latent risk. That can be more than 5 years. It can be decades. It can be forever. And forever mean when you have a containment, then forever you should do the monitoring and aftercare. And therefore, I earlier said that at the long run, containment could be more expensive than removing. At the short, let's say in the beginning, the investment in containment is low, but because of the long-term monitoring and aftercare, it's often containment the most expensive risk reduction measure. Project risk and project risk management goals. You have to manage your risks, your project risk. So not only your environmental risk, but all the project risk. And why? Because you have to guarantee safety. And examples of project risk are safety not guaranteed, quality negative influence, cost higher than calculated, execution longer than planned, the customers and our image are at risks. And the goals are control all risk during the complete life cycle of the project, have a safe and successful project, and guarantee a safe and successful use after the project completion. So these are the goals of the project risk management. And here the textbook said we need to know and manage all project risk of the remediation project when designing, preparing, and executing the remediation. So in all phases you should be aware, and especially designing, preparing, and executing of the remediation of the project risk, to manage them, to have a safe and successful project. Yes? Okay. There are 5 hallmarks of project risk management. 1, preoccupation with failure. So be aware that things can go wrong. Don't neglect signs. Don't say, oh, that's normal. Oh, I don't know. No, be preoccupied with failure. Reluctant to simplify interpretation, meaning that if you see things which are wrong or which are deviate from what you thought, you have to take that into account. Don't simplify it. Okay, it doesn't matter that it's a bit leaking. Okay, go ahead. That smells a bit, but I don't mind. So don't simplify. Be sensitive to operation. So administration is important, but the operation is of course the most important part of your remediation. So be sensitive for operation. Make sure you have the correct people that have knowledge on the operation. Give the people time to carry out their task in a proper way. Number 4, commitment to resilience. If things go wrong, have fallback scenarios, have extra time, have extra money, have staff available, have your emergency kits, have fire extinguishing materials. So commitment to resilience. When things go wrong, you should be able to act. And deference to expertise. The expert should have the final decision on technical things. So not the administrating, not the project manager, but the expert should direct when things go wrong. And on the right hand side, Churchill audit is, and you can say the project audit, the project manager audit, when things go wrong, why didn't I know? Why didn't my advisor know? Why wasn't I told? And why didn't I ask? So here you see sharing of responsibility. Not only the project manager is responsible for a successful project, but all of us are responsible for a successful project. Any questions on this one? I think it's important. I don't see question in the chat box. Okay. And this is called mindfulness. So if you take that 4 hallmarks into account in your project management, in the remediation management, you have to act mindful. The risk management principle and the origin of a project risks. 3 principles of risk management are, there are 7 origin of risks. Each risk has a cause and consequence, and risk management is a cyclic process. The definition of risk is an event that, when triggered, causes a problem. And quantification is the risk. The quantification of risk is the likelihood times impact. This is a repetition of the environmental risk assessment now, but now we're looking at all the risks of organizational risk, financial risk, juridical risk, technical risk, social risk, administrative risk, and environmental risk. So now this project risk management should cover all these aspects of the operation. Is there no possibility to monitor a site after remediation? Is the remediation process considered waste of time? The question of, I think it's Hannah, and the question is, if there is a possibility to monitor the site after remediation, is the remediation process considered waste of time? Now, my response to this is that if you have a remediation process, it's often not possible to take away all the risk because of technical limitations or financial limitations. So you take away as much as possible the risks, and the remaining risk should be maintained and monitoring in the last phase. So implementation of the remediation process is not a waste of time and money, but it reduces the risks. That's my response. Okay, so it's very important to know that you may have a remediation project, but you still have remaining risk. And the monitoring and aftercare is to sustain your results obtained in the phase 4. Let me give you an example of the Netherlands. We have many sites being contaminated. We have taken away the direct risk, the potential risk, but still there were some risk related to the contaminated groundwater. So that has to be maintained for long. And the maintenance and aftercare and the monitoring is especially true, for instance, if you have a containment by immobilization, for instance, and then you need to monitor and aftercare because situation may change and then you have to be alert. Okay. If there are no questions anymore, I will continue. This is the cyclic process of project management. This first, risk assessment. Select control measures, implement control measures, evaluate control measures. Were they successful or not? Are there new risks appearing? Update risk assessment. And through the whole life cycle of project, you do this exercise. The control measures, the best is, of course, eliminate. Take away the risks. If it's riskful to do, for instance, excavation because of the stability of a building besides, you will not excavate, but you will do a different technique. You will, for instance, start an in situ remediation. Substitute. If it's, for instance, dangerous to drive around with 20 tons trucks, you choose for smaller trucks because that's more safe for the public around the site. Engineering control. If you, for instance, have to excavate and you want to avoid collapsing of the site, you engineer your remediation pit with stable slopes. Change the way of people work. This administrative control. If you are going to do remediation and you decide to take away pure pesticides in drums, do not allow, do manual work, but do as much as possible with the machinery to avoid accidents by manual handling of the drums. And the very last one, and I have a separate presentation on that, is use protective equipment. So that's not the first one, but the very last one. First, you see if you can adapt your program to reduce the risk, and at the last, you control the risk by protecting yourself. Any question on that? Okay, the project risk assessment is actually the same system as I explained during the environmental risk assessment. You can also here quantify the risks. but you should quantify every risk. So 5 classes for impact, 5 classes for likelihood. And then you can compare and see what you have to do. Health and safety environmental aspects of the remediation site. Each remediation site is to be divided into zoning, and each zone has his specific set of protective equipment. We have zone 3, which is the clean zone. We have zone 3, which is the decontaminated zone. And we have zone 1, the contaminated zone. And here you have, for instance, your excavation. Here is the highest risk to get into contact. You may remember my slide for the drilling, and here in the drilling has also these 3 zones, the decontaminated zone, so the contaminated zone 1 and the clean zone. They're often also called red zone and green zone and yellow zone, but this is the basic. There are 3 zones, 1 where you have the largest chance to come into contact. These are the places where the pesticides are, the contaminated soil are. Then you have your decontaminated zone, and you always have to move from the clean zone to the contaminated zone through your decontaminated zone. If you go also with material, with equipment, trucks, excavators, you have also to pass through this decontaminated zone, and often you have sluices. So here is the place where you wash your trucks, but also here where you get rid of your personal protective equipment. So any remediation should have a map with the zoning of the site. And this zoning, of course, changes during operation. So each zone has a specific set of personal protective equipment to use. Contaminated zone, a maximum. Decontaminated zone, the standards, and also in the clean zone standard. And I will come to that into more details in my next presentation. But here already a picture of PPE to be used by a worker in a contaminated zone working with hazardous liquids. So this is how it looks like to be fully protected. Safety glasses, closed site, or splash guards in case of wet pesticides using. Full face mask with ABEC P3 respirator, filter, not expired. Full face mask, closed correctly on the face. Sleeves of Tyvek should be over the gloves and over your boots. So you wear this over your boots, otherwise contaminated material will enter into your boots. Hard hat, Tyvek, the type, gloves and boots. So this is how it looks like when you go. I will give you more details on the specific personal protective equipment in the next presentation. Examples of zoning in practice. This is, for instance, an example on the left-hand side of Vietnam. It's remote. There are not much facilities, so you build your own zoning. And this is the decontaminated zone for personnel, for staff. The clean, this is to the clean zone, this is from the contaminant. Here also the decontaminated part is divided into clean and contaminated. So racks for Tyvek, barrel for dirty PPE. So if you are done, put all your used PPE in this drum, which is waste, to be treated as waste, a bucket and water to wash your hands and face, and a bowl for water to wash your boots, or a boot cleaning station. Here in this part you have your first aid kit, and also you put here your clean clothes. This is another example. This was in Georgia, somewhere also remote. Here again a division, clean clothes. Here's material to clean your hands and boots, and this was the shelter in the sun in the clean zone. Taking pause, taking rest should always be done in the clean zone. Never eat or smoke cigarettes in the contaminated zone. An exception is made for drinking, especially in hot climate. Then drinking should be, you should make a drinking station where people can drink, because drinking in warm climate, and especially when you are with Tyvek on, it's important to avoid heat stress. Phase 5, monitoring and aftercare. So when the remediation is completed, phase 4 is done, you have remaining risk, so you enter your phase 5, which is called the monitoring and aftercare. Design and report a monitoring and aftercare plan for the monitoring and aftercare measures. So when the remediation is completed, you need to report what has to be done to maintain and to monitor the situation as it is. Inspect and repair contaminated measures periodically. On the right-hand side, you see an example. This is an example for Vietnam. This was a phytoremediation plot, and we constructed a wall below the groundwater level. The groundwater level was very shallow here, so to avoid groundwater migrating the contaminated topsoil. But the climate here is, in the rainy season, heavy rains, and the neighboring people want to get rid of their excess of rainwater, and they just open this wall to allow their backyard to be drained off through the contaminated soil. With this, the migration of contaminant was enhanced. So this, of course, was repaired, and the mistake was that the people were not informed properly on what should be done and what should not be done. Plus that if you do such containment, you should take care of the problems originating from your implementation of your measures. Okay, so inspect and repair. Sample and analyze. Here, groundwater, the number, sample and analyze half yearly, yearly, depending on the situation. In this case, this was also in Vietnam somewhere, but then at another site. Here at the back, we installed a permeable reactive barrier with peat to protect the rice field, which were downstream, from the migration of contaminant groundwater. The groundwater was running through the permeable reactive barrier, and the peat was absorbing, is absorbing, the barrier is still there, is absorbing the contaminants. And here, after the barrier, downstream, we were monitoring the groundwater quality and see if it works. If it don't work, you have to take action. So sample and analyze drinking water, sample and analyze surface water, maintain land use and groundwater use restriction, report and monitoring after results periodically. So if you have your monitoring result, you should make reports and share the information with the stakeholders. The information of the reports should be used to update your conceptual site model because the situation changed. And based on that, you update your monitoring and aftercare. Situation change, maybe the frequency of the sampling can be reduced. And an important aspect, allocate yearly budget for the monitoring and aftercare and inform stakeholders on the results. And this process continues until the remaining environmental risks are eliminated. Any question? Okay. So this is the summary of all the phases, the deliverables. So initial conceptual site model, the preliminary risk assessment is the input for phase number 2, gap analysis, update conceptual site model based on the results of the detailed site investigation. Then you can confirm the risk, your risk assessment. This goes into phase number 3, the remediation assessment. Select remediation techniques and for each site component. This was discussed in model 5. Conceptual design, remedial options describing feasible remediation measures for all site components. Select the best remedial options on risk reduction, environmental merits and cost. In this process, you have collected new information, is update your conceptual site model, and then preliminary design the best remedial option. Then it goes to phase 4, the remediation management, detailed design the site remediation, eliminate acute risk, contain the remaining risks, and then it comes to the monitoring and aftercare if you have remaining risks. And the information should be used to update your conceptual site model. And here are the different site components. So stockpiles, inventory, repackaging, plan, repackaging, and monitoring. Content building assessment, decontamination plan, decontamination, and if necessary, monitoring and aftercare. Buried pesticides, pit inventory, excavation plan, cleaning of pit. Contaminated soil and groundwater survey, your remediation plan, remediation, and in most cases, this site component has to be carried to the last phase, the monitoring and aftercare. So these site components, I was wrong now, just a few seconds. These are often being taken away and no remaining risk. In most cases, contaminated soil and groundwater after remediation have remaining risks. Any questions? Because this is the full scope of contaminated site management in a sustainable way in a nutshell. I tried to be complete as possible in this infographic. No questions?
I don't see any.
Then we come to the last 2 slides of this presentation, which is the flow diagram of phase number 4. Detailed design selected the best remedial option. All technical issues are covered. No additional technical survey and update conceptual site model, and you go back. Implement remediation and update your conceptual site model. So you have changed the situation. So you update your conceptual site model. All risks are eliminated. Yes. Okay, you can finalize. No, not all risks are eliminated. Perform a 2 or 3 risk assessments. All risks are assessed. Yes. Are acceptable. Yes, they are acceptable. Finalize and go to phase number 5. If they are not acceptable, if they're not acceptable, you go finalize number 4 and you return to phase number 3. You see what to do to get rid of these risks that are not acceptable. Then number 5, the flow diagram of the monitoring and aftercare. Make monitoring management and aftercare plan, monitor and aftercare, and update your conceptual site model. And if the contaminants are removed, yes, you finalize, you go outside. If not, contamination stands still or reduces, then you just continue. If it's not standstill, if the situation changed to the worst, you perform again a risk assessment. All risks are assessed. No, return to phase 5 and return to phase 3. Here, risk assessment, yes, are acceptable, yes, you come here, and no, you return to report phase 5 and return to phase number 3. This is the process of the flow diagram phase 5. Any questions? Then I would like to thank you all. And have you really assessed all risks? This is just a joke? I don't think so. It's very difficult to get all the risks assessed.
I see that you changed the cat by the rat.
Yes. Okay, I'll go to the next presentation. This presentation is on the protective equipment and respiratory protective equipment while working with POPs. And POPs stands for persistent organic pollutants. The content. I made several links in this table of content because it's a quite extensive presentation. So this presentation, this lecture is about personal protective equipment and respiratory protective equipment. So the content of the presentation is the objective first. Then what is personal protective equipment? Why should we bother? Issues to be considered before selecting, toxicity of components at site, and then we go into more details about the different types. You have overalls and cover overalls, gloves, safety footwear, eye protection, hearing protection, and respiratory protection equipment, and then the general rules for the equipment. The objective of the lecture: explain what protective equipment is, explain how to select, and explain how to use. And the motto is take care of each other so that you can come home safe. So what is PPE? Personal protective equipment. The final line of defense against hazard. So not the first. You remember the triangle I showed you earlier? It is the final line of defense. Protection from physical hazard, for instance, a hard top, hard hat, or 2 cap top boots, so the boots with the safety boots, protection from chemical hazard, gloves or vapor mask, and you should allow workers to carry out a task in a hazardous environment without harm. Therefore, you use PPE. You cannot avoid to work in a hazardous environment, so as the last line of defense, you use PPE. But before, you make sure that you design a project as safe as possible. Why should we bother? You will come into contact with toxic material and you want to stay healthy and you do not want to take the hazards home. And therefore you need to assess the risk on what needs to be done, avoid exposure, protect yourself, and eliminate manual handling or handling as much as possible. So if you enter a pesticide site, you need protective equipment because you have the risk of exposure. And you will see several infographics here. I use these infographics to illustrate. So if you have here the situation you have to move these drums, you can do it manually, but the risk is there that you hurt yourself. But best is to use material, work in a group, and have a minimum of handling so that you come safe home. Actually, this is a picture from a game which I always use to instruct people who are not familiar with the concept of risks. I have a set of around 20 scenarios, and these are different cards, and then the game is as such that you select the scenario, you select the bad behavior and the consequences, and you select the good behavior and the consequences. You can make such thing by yourself, and it helps a lot to raise awareness within your team who's not familiar with this kind of work. Issues to be considered before selecting the personal protective equipment. Identify the type of hazard or the chemical of concern. Establish the level of the hazard. Identify the effects on the body. Identify the potential route into the body, assess the likelihood of the exposure, dus the risk, and what is the duration of the exposure. These are all elements to be considered when selecting the PPE. Other factors affecting the selection of personal protective equipment is the work rate, the wear time, medical fitness of the wearer, the mobility. Do I need to be very mobile? So what should I use to be mobile? Working environment, climate condition. I told you earlier that if you use Tyvek, it's very hot, so you need to drink a lot of water. So if possible, avoid using Tyvek. If possible, if the situation allows. Sweating, exhaustion, and compatibility with other PPE, meaning your mask should be in compatibility with your glasses. Here an example. The man has a beard. He wants to use a full face mask, but the beard will cause leaking, so he will be exposed, so the consequence is that he will be affected. So if you have to use a full face mask, you have to cut off your beard and then you stay healthy. Toxicity, according to the regulation number 1272 and from 2008 of the European Parliament and the Council of 2008, division into acute toxic, chronic toxic, and then you have oral, dermal, and inhalation aquatic, carcinogenic, and specific organ toxicity. These are the subdivision of toxicity, and this gives an impression of the toxicity and the necessary personal protective equipment. Safety data sheets of material provides best information. Available online. Here, this is the link to safety data sheets. Also in your guidelines, these are available. Toxicity is expressed in LD50 and LC50. This is the dose and this is the concentration, LD and LC. Toxic rates, you have the classes, rating 1, 2, 3. Commonly used terms, extremely toxic, highly toxic, moderate toxic, slightly toxic, particularly non-toxic, relatively harmless. And here are the doses given. And for the doses for the LD50, so the lethal doses and lethal concentrations. This can be consulted and this has to be done by specialists. Toxicity of the components, given codes should be included in the labeling of the material. And this is extensively discussed in the FAO Environment Management Toolkit I earlier mentioned. So I took here an example of HEA, which is lindane, and its byproducts, its isomers. And here this is DDT, 2,4-DDT, dermal, class 4, inhalation, class 4, oral, class 3, carcinogenic 2, acute aquatic toxic, class 1, and chronic aquatic toxic 2. Now, hazardous statement of the global environmental harmonization system of the classification of labeling of chemicals, and this is in the Basel Convention, and here are the codes to be used. Now we go to the different type of PPE, so when you have the selection done, and if you select PPE, always consult your supplier. What is available, and the supplier knows exactly if you have a good characterization of your contaminant, the supplier should know what you have to use to have the full protection required. There are, of course, different types of PPE. The main difference is reusable and disposable. Reusable can be used multiple times. Disposable can be used a single time or sometimes 1 or 2 times more, depending on the situation. Reusable are often ready available. Now we talk about gloves, boots, hard hats. These are reusable. They can be obtained by local suppliers. I think also in your country you can get this. Per unit they are expensive, but the total cost is relatively low because you buy them once and you use them, you clean them, you use them, so they are the total cost is relatively low. But they need to be cleaned, they need to be maintained, and you make sure that your risks are not taken home. So your materials should stay on site, and if the project is finished, they should be properly cleaned. And of course, reusable are not suitable for all materials. Sometimes you need to have disposal. They are cumbersome and hot, but ventilate. For instance, if you have an overall, a cotton overall, it's cumbersome, it's hot, but you can ventilate and can be used many times. Now we come to the disposable PPE. Often they may have to be imported. They're not available, ready available in countries. You have different international suppliers. DuPont, 3M, and so on. They're cheap per unit, but the total cost is high because every day you have to buy them. Every day you have to replace for instance, your cover overall, and then they will exceed the price of this reusable. Disposable cannot be cleaned, no maintenance. Proper disposed hazard, not taking home. So meaning you have to get rid of it, and when they are used, they are being treated as waste. You can select them based on the actual hazard, easy to use, but also no ventilation, used once or for a specific time. And then for a specific time, for instance, gloves. I mean, you can use gloves for several times, but at the end you have to get rid of them. So they are in total low, they are expensive. They are difficult to maintain, to obtain. You have to use natural supply, they can be locally. PPE needed when working with POPs pesticides and POPs contaminated soil and groundwater. International standard of performance of PPE. Personal protective is not the first line of defense, and a worst case scenario should be adapted for unknown substances. So when you select PPE, you take care that you have a worst case scenario, so you be ready for the worst. Now we come to the different items. First we'll discuss cover overalls and overalls. So cover overalls are disposable, overalls are non-disposable. Then I'll discuss gloves, and gloves in general can be used several times but are disposable. Safety footwear is non-disposable. Eye protection, non-disposable. Hearing aids, hearing protection, is disposable or non-disposable. Then we come to the respiratory protective equipment and the general rules of using them. Let's go to the coveralls and the overalls. Type of coveralls. You have type 1, protect against liquid and gases, and then they are more or less equal or equivalent to the US type level A. You have type 2, protect against liquid and gases, non-gas tight, more or less equal to the US level B1. Protect against liquid and chemicals, liquid tight, protect against liquid chemicals for a limited period, so spray tight, more or less equal to the level C of the US, and protect against chemicals for a limited period, and they are more or less equal to the type D used in the US. And then you have type 6, protects parts of the body against liquid chemicals. So these types are the coveralls, the types, and on the packaging of these types you find these labels to illustrate type 4, type 6, and here other labels that are on the packaging. So if you buy and you want to check if you have the correct ones, look at the labels and at the pictograms, and you see where they are used for. Coverall types protects against liquids and gas chemicals. Gas tight, more or less equivalent to A. Here it is. Very uncomfortable, but protects fully. Type 2 protects against liquids and gas chemicals, not gas tight, more or less equal to B1. Here we are. This is the type. And type 3 protects against liquid chemicals for a limited period, liquid tight, liquid jet proof. Type 4 protect against liquid chemicals for a limited period, spray tight, more or less equal to C from the US. Liquid splash proof coveralls, typically worn when handling low hazardous pesticides. Protect against liquids. That is this one, and this one is this one. Sorry, type 4 is this one. Only covers the body partly, meaning that you still have your hands and face open, more or less equal to day. Dust and low hazardous splash, suitable for using most solid pesticides. So this is what we use mostly. Cotton, reusable. So this is a cotton, this is disposable. Don't compare in terms of material test and leak test. Provide nominal protection for liquid or fine dust. Washed, passive exposure to laundry. So if you have these overalls, you should inform your laundry company that they are exposed. So they use also protective equipment, they use gloves. So when you use these overalls, those cotton overalls, and they have to be washed, you inform your laundryman that they are contaminated and that they should have gloves when they handle these overalls. And we use this during our survey, unless it's very toxic and so on. But this is commonly used. They have often a zipper, no buttons, but the zipper, and no pockets, because pockets can collect soil. Synthetic reusable or disposable, higher level of contaminant resistance, and there's a variety of types exist. Okay, selection of coveralls, disposable or reusable. What chemicals will be handled? What is the kind of likelihood of exposure? And what will you be doing, and what mechanical strength is needed? Disposable, a wide variety of types, a wide variety of manufacturers. Each type has a European norm, most commonly used, and here are the companies: 3M, DuPont, Kimberly-Clark, and Shillon. But new developments are being made all the times. And I would purposely want to address an issue, which is an upcoming issue. These materials that are used to make these Tyvek or cover overalls may contain PFAS or PFOAs because they are not water absorbing, they're fire resistant, but they are having pops, the PFAS, the new pops. So be aware that if you are working with these overalls and you have a survey for these new pops, you have to select equipment, personal protective equipment, not containing these components. And that's a new development. I have not seen them yet, but they will come soon. Use of coveralls, how to put them on. Before putting the coverall on, check the specifications, check for tears and rips and elastic cuffs, check the manufacture date. These disposable or cover overalls have a date, and there's a shelf lifetime. So after, they're mostly in years, they expire. They're not effective anymore. But if you wear them, they should not be too tight. They should not be too wide. It should allow free movement, bending, stretching, etc. So before you put it on, see if they have the right size. And if you've put them on, see if you can bend and stretch and that they do not obstruct. If they do obstruct, you have to select another size. So this guy has put on his disposable coverall. And can you tell me, normally I ask them what is the mistake here, but these are the mistakes. It's not closed. His sleeves are in the gloves, so material can enter. The boots are, the trouser is in the boots, so material can enter, so this is not good. The zipper should be closed. This is better. So if you wear these overalls, it should be over the boots, over the gloves, and the zipper should be closed. This is even better. This was during a project in Turkey, and here, safety helmet, safety spectacles, half face mask with ABEC P3 air filter, disposable cover overall, double gloves. So he has gloves, but inside he has nitrile gloves, and I will advise you to do that, because if you take off your cover overall, you take off your gloves which are dirty, and then your hands are in nitrile gloves, and your hands can be used to further undress yourself and touching the contaminant parts. Here you see that we tape the sleeves so they are fixed. And here we have a simple belt bag with our stationery. If you have to write things or you need a notebook, you use your belt bag, because these overalls, these cover overalls, have no bag, but you need to write. And this is at the end of the project also contaminated and should be disposed or cleaned thoroughly. And here, the last but not least, chemical resistant safety boots with the legs of the cover overall over the boots. This is very uncomfortable when it's warm, and therefore your working time should be adapted to the situation. And if it's warm, you should allow breaks frequently for drinking, and there should be always a watchman watching people operating under these conditions. And when you see that things go wrong, you can act. The watch is also standing not in the contaminated zone, but in the decontaminated zone. And this man is monitoring the operation, but also monitoring the PPE. So monitoring if things are still intact. And are you comfortable or not? It is compatible with the other PPE. And are there any tears or rips? Now here examples of damaged cover overalls. Here this guy. And then it should be changed. So the watchman then call on, come out and change your overall, your cover overall. So if it's the protection from your coverall is compromised, stop working, leave the working area, carefully remove your damaged cover overall, put on new one. And if the problem persists, review your selection. So he reviews his selection, he should take a bigger one. Any question?
I don't see any hand raised and any comments, so you can proceed.
Okay. Now I have some slides on how to remove safely your coverall when used. And the basic assumptions are that the outer surfaces are contaminated. You have to remove the contaminants from the side. Do not touch outer surface unless you have gloves on, and follow the following 10 steps to get rid or to undress yourself from your cover overall. Ask for assistance. Assume the outer surface is contaminated. Clean contaminated part. Do not touch the outer part unless you have gloves. And that's why I said have inner gloves. But you start by removing the zip cover if present. Remove outer gloves, keep inner gloves on, loosen other gloves, and unzip and remove other ungloved arm from the cover overall. So he now takes off his outer gloves. He has this on this picture, he does not have inner gloves, but he should have inner gloves here. Make sure that your gloves are being disposed as waste, so shake off the other gloves. Put the gloves in a waste bin. Reach inside the cover overall towards your shoulder with free hands and with inner gloves, touching only the inside of the overall. Free the other arm from the overall. Reach inside the overall towards the other shoulder with your free hand with the inner gloves. So here, then remove top half of the cover overall without touching the outer surface, but then strip it off. The inside of the coverall is facing outside. Pull down the cover overall to the ankles. Leave the boots inside the removed overall. Here are slippers, so you take off, you leave the boots there, take the slippers, step out the coverall, pull from the inside the boots out, fold the coverall into a ball so that the contaminated part surface are inwards. Dispose as pop pesticide waste, add and remove inner gloves as last, and dispose as pop pesticide waste. So this one goes and this one goes. These are the 10 steps. Normally in the training we exercise this before we go to the field, but if you are starting a project and you are going to remediate, I would advise you to have a training, a practical training on this aspect. Use coveralls and other disposable PPE are waste. Assume that they are contaminated, but do not underestimate the value of coveralls or its components. Zips are removed and sold and used, and these coveralls are sometimes seen as a status symbol. Package and label the used PPE and for disposal as pop waste. So all the disposable PPE should be packed and seen as waste, and they follow the same route as your waste being treated. Then we come to the decontamination of overalls. The overalls, the non-disposable, should be washed differently, but use a clean overall each shift or day depending on the situation. Inspect also for rips and tears after every use, and dry in the sunlight if possible. Don't use a machine, but dry in the sunlight. Store a washed coverall in a clean and sealed non-porous bag. So when they are washed, store them in a bag so that it's clear that they are cleaned. Cover overalls for HCA and cover overalls for lindane and DDT contaminated sites. And then we come here according to the soil safety data sheets for both HCH and lindane and DDT to have a complete protection against the chemicals. The type of PPE equipment must be selected according to the maximum concentration and the amount of dangerous substances at the specific workplace. And based on experience, we use for Tyvek type 4-5 when working with solids, and Tyvek type 3 working with liquids. And in case of exposure when working with Tyvek 4-5 is visible, then upgrade to Tyvek number 3. So this is what we use normally when we work with pesticides. So type 4-5, type 3 when liquids, and when 4-5 is still giving exposure, we go to number 3. Summary on this overalls and cover overalls. The difference, we discussed the difference between the usable and disposable, how to select. Consult your supplier, but inform him about the hazards, the toxic, the chemicals, the route of exposure, and other factors. We discuss how to wear and we discuss how to remove. Any questions on the overalls?
I don't see any hand and any comment, but please feel free to ask whenever you consider that it's necessary, because Mr. Fogg, from the beginning, he's asking the feedback from the participants. So if you have any question from this slide or the previous slide, don't hesitate to ask. Please, we continue for the moment.
Okay, we'll continue. Now we come to the gloves, and gloves have to provide chemical resistance. There are many different polymers that are used to make gloves. The material selected depends on the compound of the contaminants, actually the same list as for the overalls, the pesticides and or solvents, water or organics, the level of exposure, the thickness of the gloves. Gloves provide physical strength. Polymer gloves may have little mechanical strength. Heavy-duty gloves may be required. Leather gloves provide no chemical barrier. So here is the chemical resistance and the physical resistance. But be aware that the strong gloves, especially from leather, have no barrier for chemicals. So depending on the work, you select the correct gloves. Here are some types: leather, PVC, natural, nitrile, and this is the one we normally select: cotton, latex, and these are the inner gloves. Nitrile gloves as inner gloves gives better protection. No latex inner gloves should be used, it should be nitrile. Latex is permeable for some chemicals. But you have here this latex long sleeves There are also, I should have added a picture, but there are also long sleeve gloves, non-latex. But these long sleeve gloves are preferably used when you work with liquid. When selecting gloves, consider exposure route, thermal, hazardous waste class, characteristics of the material to be handled, the chemical strength needed, the likelihood of contact, and the likelihood of duration, the job to be done, the chemical resistance, the physical strength, and the gloves must be fit for the purpose. So, meaning that if you have a project and you have heavy duty work lifting of clean contaminants, of clean material, you may choose for leather materials. In the contaminated parts, we use often this one to make sure you have enough spare, because they are not so mechanical resistant. And always use neutral gloves as inner gloves. So glove selection is based on contaminant experience and activities. Recommendation: use neutral gloves as inner gloves. Tape outer gloves on the sleeves of the overall. Use neutral gloves for sampling. Thick and thin gloves depending on the activities. Here you see, here we go inside the store for work, they are taped. Here again the example working on a HCH and Lindan contaminated site. The minimum for handling HCH, neutral gloves. The maximum layer thickness should be 0.11. Breakthrough time 480 minutes. For handling DDT, standard chemical gloves, this type. So all the gloves also have their types and their coding in accordance with the EU directives. Summary of gloves: contaminants may be absorbed through the skin. Latex in this respect is not suitable. There are many types of gloves. Check the safety data sheet for the appropriate type. They protect against dermal exposure and absorption. Select one type for multiple tasks. So try to select one task for multiple tasks. Tape sleeves of coverall on the sleeves of the outer gloves. Inner gloves improve protection. If there are no questions and the translator has finished, I can go to the next slide. Can I go to the next slide? We come to the safety footwear. No leather boots and boots with laces should be worn. Boots should have steel tips and soles. Boots should be chemical resistant. Coverall should cover the tops of the boots. Chemical resistant overshoes are an alternative to boots. When can these be used? Should be discussed, and these should be cleaned before removing. These are the alternative, but these are not very usable for work. This is not very usable day wear. Only when you have visitors you use them. For walking and working they are not suitable. These are suitable, these are suitable. This should not be used because they have leashes. And these leather ones, yeah, they're very comfortable. These are not comfortable, but they should at least not be used in wet conditions. Dry conditions, okay, they're comfortable. They're rig boots. But preferably we use this type, and especially when we work with liquids. Okay, we come to the eye protection. Safety glasses, good for direct eye protection. No brow protection. So the glasses are good for direct eye contact protection, but doesn't protect the brow, sorry. Do not allow you to wear your own glasses, and no side shields. Improved glasses cover brows, side shields, no steaming up, and comfortable to wear. Here, these are the improved safety glasses. Goggles, this one covers brow as well, have side shields, that's closed, and preferably with a non-absorbent strap. Most these straps are elastic and they can absorb, but preferably they should be non-absorbent. But they steam up, they're very uncomfortable, especially in warm and when sweating. The shields, good coverage of face, only for spray hazards. Here, when you spray, then they are good, but for vapor, they're not good. This is actually the best, but very uncomfortable. All protects against flashes, they all protect against splashes. Do not offer real protection from dust or vapor. The dust and vapor can come in. Combination system provides the best dust and vapor protection for eyes. Examples are full face mask or air hoods. So then the face mask is also protecting your eyes in the full face mask. And air hoods are the complete helmet with everything on it, and then it also protects. Improve safety glasses offer relatively good protection with a maximum of comfort. Eye protection glasses, shatterproof, splash resistant, no vapor, no dust, no eyebrow protection. Goggles, eye totally enclosed, limited view, steam up, uncomfortable, limit vapor protection, can be used with own glasses, with your own glasses if you wear glasses. Steam up, condensing of your sweat on the glass of your goggles. You get condensed and then you don't see it. You understand what I'm saying? Face shield, comfortable, good total view, eyes are not enclosed, vapor protection, no vapor protection, and can be used with your own glasses. And they do not steam up. Okay, next one. We come to the hearing, only needed for in case of noise of machines such as drilling rig and excavators, mostly not needed for non-mechanical work, can be used in combination with safety helmets. So this is very comfortable, and these are the other hearing protections, so single. I think it's important to use this, especially when you are in a noisy environment. You can easily damage your hearing by noise, so please consider using them when it's a noisy environment. Now we come to the respiratory protective equipment. The objective of this part of the lecture is to appreciate how masks protect us, to understand the different types of masks, to allow us to select the best mask for conditions we will work in, and issues we discuss is exposure routes, type of hazard, measurement of toxic hazard, types of masks and filters, and the use of the masks. So this is actually the basics. You have a vapor, you want protection, the vapor goes through the filter, enters the inside of the mask, and you have clean air. But this mask, where this clean air is, will always leak to a certain extent. The RPE protects the exposure routes, inhalation from vapor, mist and dust, inhalation fine contaminated soil particles, inhalation of aerosols, inhalation of dust and asbestos, and ingestions. So these are the protection of the exposure pathways when you use a mask. So this guy, full face mask, and here he gets the air supply from behind, but he protects against vapor, mist and dust, fine contaminated soil particles, aerosols, dust, asbestos, and ingestion. For toxic hazard, we use the LD50 table I showed you earlier, legal doses in milligrams of substances per kilogram of body mass, and the same for the concentration of vapor exposure. When C is concentration and T is the time, it's often expressed in terms of milligram per minute per cubic meters. That's the unit. Yeah. To measure the concentration in the ambient air, we use PED, this photoionization detection, and you measure your volatile organic components, the VOCs. Gas detection, multi-test tubes, there are different types. So with this gas detection tubes, you can measure also the component which is in the air. And multi-gas meters, these are more robust and more reliable. The entryway, and they can use CO, H2S, oxygen, LEL, the lower explosive limit, and then the VOC. And they can have an alarm in. So you can enter your maximum allowable concentration, and then it gives an alarm when you exceed. Comparable measurements with limit values, here that's the MAC. This is the maximum allowable concentration. And the IDLA, the immediate danger of life, of health, this value should not be exceeded. So you have the max and you have this one, and max is what you still want to allow. When you exceed on this multi-gas meter, you get an alarm, and this should be avoided at all times. Odor detection threshold. Odor detection threshold is the lowest concentration of a certain odor compound that is perceivable by human sense of smell. The lowest concentration of the substance in the air that still can be smelled. That's your odor detection. And now we come to an important remark. The exposure risk is high or very high when the odor detection threshold is higher than the limit value. So be aware that there are substances which cannot be smelled or sensed by smell, and then they are higher than limit values. So read your safety data sheets on the components and see what the odor detection thresholds are and compare that with the limit values. Measurements of respiratory protective equipment, toxic hazard. Is the material a dust or vapor? Is the exposure route ingestion or inhalation? Toxicity of the active ingredient via LD50 or L odor concentration and the class. Toxicity of the formulation via calculation, and reassess the class. Then this gives a toxicity hazard. This should be done by a specialist on health and safety. Measuring air quality measurements depend on toxicity of the substances and the occurrence of dust, POP, the persistent organic pollutants, in general have low or no volatile, and the exposure risk inhalation of dust. That's the most important exposure route of POPs, inhalation of dust. So the dust measurements are the proxy for the potential exposure to POPs, because POPs are low or non-volatile, and they are mostly on the small particles of the soil, which are easy to become airborne, and thus the risk of inhalation. So dust protection, dust mask is the most important aspect when you work with POPs pesticide remediation of soil. Air measurements versus contaminants. So this is your volatile component, exposure and dispersed, and this is the wind. It uptakes the dust of non-volatile components, and then you are exposed to dust. If it's volatile, you're exposed to vapor, and if they're non-volatile, you may be exposed to dust, contaminant dust. There are two types of respiratory protective equipment: air filtering equipment and air supplying equipment. Air filtering, you have disposable and reusable. The type of protection selected depends on the hazard. During remediation, mostly air filtering equipment is used, and we use reusable full face mask and disposable filters. Reusable half face mask. These are full face masks, and I had a picture of a half face mask, and you have disposable half face mask. And then you have air supplying equipment in case of a very high dust concentration or confined spaces, and then you are supplied with air. Here, these are air supplying. You have your bottle on your bag, or you have a host supplying clean air. I told you I have some pictures of disposable vapor mask, and this is a half-face disposable vapor mask. And here are the filters that can be reconnected and be disposed. This is a reusable full-face mask. This filter is of course disposable. Here you have this reusable power air respiratory equipment or system. You have this helmet with your mask, with a sleeve inside, protecting you from exposure to dust. The air is being supplied by units which you carry on your back. And this is very comfortable in hot weather, because it also gives a cooling of your air. When it's cold, it's very uncomfortable. And here are the disposable dust masks. There are many types, but they all should have I always advise to have the maximum protection, and that is the protection class 3. Any questions so far? I will speed up a bit. Definition: a respiratory equipment depending on the ambient air purification respiratories. Air from direct surrounding is filtered, and the filter air is breathed. So here are the different types again. Definition: independent from ambient air. Supplied air is taken from a clean source and transported through hoses. Self-containing breathing apparatus is air supplied from a compressed air in a cylinder. Both can be used in toxic air and air deficit atmosphere. So they are used when there is not enough proper air to be used. Then we come to the use of mask and the pre-use checks. Always use only use before the expiring date of yearly test. So these materials, these equipment should be tested, and they should only be used before the expiring date of the yearly testing. But it should be checked regularly prior to use. Checks should involve cleanness, no dirt or detergent, and inspections of delicate parts. Additional factors influence the mask selection: face type and shape, work rate, wear time, non-wear time, medical fitness of the wearer, communication, contamination, and compatibility. And I would like to mention the communication. If you have your full face mask, it's difficult to communicate because your speaking will be limited by the mask you have on. So before you start working, make agreements on communication by hand. Disposable mask: the supervisor must ensure that all use this disposable mask is packed for disposable as well. As with overalls, do not underestimate the value of these masks. Always assume that the masks are contaminated. Storage of reusable masks: masks need to be clearly identified with user names, start date of disposal. After washing and drying, they should be stored dry, cool, clean, and non-porous bag or container. Selection of the type of contamination: dust or fine particles, organic vapor from pesticide, organic vapor from solvent, may be additional hazard from solvents such as flammability, may be additional hazard from chemicals such as irritant, for HA and DDT, etc. So the selection, also the working area, the season and climate, physical conditions, and the type of work, they all have to be taken into account when selecting. For each hazard, there will be a certain level of protection. Level of protection is shown by a number. Each category has a rating of 1, 2, 3, and 3 offers the greatest protection. I've told you that for dust, we use always the maximum protection, which is 3. So dust mask should be P3. Protection rate factors relates directly to the published data on hazards, and the nominal protection factor, this NPF, the minimum level of protection of the respiratory equipment, has to demonstrate under laboratory conditions to gain approval to the appropriated class for the performance standard, and it indicates the rate between the concentration of the contaminants in the ambient air and inside your respiratory equipment. Then you have the assigned protection factor, the minimum level of protection calculated for 95 of the trained wearers using the equipment in working places. It's determined with test under severe conditions such as insufficient maintenance and improper use of the RPE. So there are nominated protection factors and assigned protection factors, and this should be supplied by the supplier. By the selection, you take the assigned protection factor. Yeah, okay.
There is a question, there is a new question, but I wanted to keep for the end of the presentation. But in any case, the question is, in case where small vehicles are used to reach the target location, what about their wheels, outer structure, and contamination in the places where people place their feet?
When you enter your sites with small vehicles, I told you that you have to use the zoning. And the picture of the zoning, you have your decontaminated zone. So you enter through the decontaminated zone, your contaminated zone. And if you go out, you enter again the decontaminated zone where you do the decontamination, where you clean your wheels, where you clean the outside of the vehicle. And then when it's clean, you go out. So the zoning is an important aspect of not taking contaminant parts outside your contaminated zone.
Greatly appreciated. Very well explained. So if anyone has any other question, please put on the chat on this, and when Budwin will end the presentation, I will ask to him. So don't worry. Continue, please, Budwin.
Yeah, this is maybe a bit complicated, but if the assigned protection factor is 5, then the concentration inside your mask is 5 times lower than the concentration outside. So if you have a concentration of 100, then it's 5 times lower inside, so it's then 20. Examples of assigned protective factor. A full face mask has an assigned protection factor of 20. A half face mask has an assigned protection factor of 10. And a dust mask has an assigned protection factor of 5. So the full face gives you the maximum protection. So if the outside concentration is 100, then inside 100 divided by 20 is 5. So you will always have to take into account the assigned protection factor. Yeah. And now in practice, the gas concentration is 200 ppm in the ambient air. The limit value of this volatile compound is 15 ppm. So you are allowed to be exposed to 15 ppm. The selected filter, you select a filter of class 1 filter, which is sufficient for a maximum concentration for 1000 ppm. So the filter is okay. The selection of the mask, you select a half face mask, which has a assigned protection factor of 10. Then you calculate 10 times the limit value is 150, and 200 is more than 150. So conclusion, this combination gives insufficient protection. Is that clear? Because of the assigned protection factor, you cannot use in this situation with this concentration a half face mask. Now we come to the next one. The gas concentration is still the same. The limit values of the volatile component is still the same. The gas filter has 1, that was okay. But now the half face mask has an assigned protection of 20. Sorry, full face mask, yeah. Sorry, I'm getting tired. The limit value is 20 times 15 is 300. 200 is less than 300. So this combination is... So the message is, if you select your mask, do these calculations or ask your supplier to do the calculation, but then you have to give him the expected concentration in the air. Okay, we come to the next slide, determination of the needed protection factor for the respiratory protective equipment. Contamination is DDT and lindane dust. concentration at the workplace is 1.8 milligram per cubic meter during inventory. Occupational exposure limits for DDT and HA are 0.5 milligram per cubic meter. The minimum protection factor concentration of DDT in the dust is 1.5 divided by 0.5 is 3.6. PE with the assigned protection is 4 is just enough. Recommended to use here again P3 filters to provide a better and safe margin, especially since DDT and HA are persistent organic pollutants and potentially carcinogenic, and concentration will be fluctuated when working. So this is an example for dust. This P1 is enough, but we said don't do it because you are going to work and use the maximum protection. So filter classes for dust P1, P2, P3, low, high, medium, and the assigned protection factor is 4, 10, 20. Yes? Okay. Be aware that doubling the respiratory rate lowers the lifetime of your filter. So if you work very hard, your lifetime of the filter will reduce. Relative humidity above 65% lower also the lifetime. So when it rains and the humidity is high, be aware that the lifetime of your filter is being lowered. Every 10 degrees increase starting from 20, reduce the lifetime of your filter with 10%. And when a cocktail of compound is present, take into account the total load and not only the single toxic substances. So when you get your filter and you have a cocktail, you should not use the single toxic, but the full load. Selection of the type of contaminant, selection of the respiratory protective equipment, the type of contamination. If you have a risk to be exposed to volatile, you use gas with vapor cartridges, so the vapor cartridges, vapor filters with active coal. If you have risk to be exposed to dust, you use dust maskers, so particle filters, P. If you have the risk to be exposed to both, you use combination filters, this dust filter with a vapor filter. The golden rules: never use filter passing expiring date, clean filters and mask after use when you can use it the next day. If there's any sensory observation you are wearing, check if correctly used. If persists, change filter. Before start, be aware the components and their odor detection thresholds, the weather forecast, and the needed other PPE and its compatibility. Now, this is the coding used on the filters. And here the different codes, the colors, tells you what is protected. For instance, here black is carbon monoxide, red is mercury, blue is nitrate gas including nitrous monoxide, and so on. And here the P, white color, is against dust particle size. So any filter has a color banding, and this color banding gives you the protections. And we always use the combined filter because it protects many different hazards against vapor, brown, particle, white, acid gas, yellow, ammonium, green, and it has here the expiry date and the certification mark. And this is often what we use on a full face mask, but also on half face masks. Here again in letters, so A, AX, P dust, vapor classification, class 1, 2, and 3, dust 1, 2, and 3. Example, ABEC A2, B2, E2, K2, P2 is a filter for working in situations in inorganic gases, sulfur dioxide, ammonium, and ammonium derivatives till 500 ppm and 48 times protection for the OLAS dust, for the dust. Yeah. So this is what we use. The suggested filter to use at soil remediation project for POPs contaminant site is A2, B2, E2, K2, and P3. Multi-use filter for organic and inorganic gas, sulfur dioxide, ammonium derivatives, and dust. Preferably on a full face mask. Detailed risk assessment can give insight in vapor protection. If you do a detailed risk assessment, gives insight, you can go lower. But this is advised. Selection: where are you going to work? Enclosed space, never use dependent respiratory protective equipment, moving parts, or risk for jamming and wedging. Never use hoses. So enclosed, never use dependent, but have your air supplied. Like this. You should be fit to wear. What are you doing? Respiratory should be liquid tight, should be tight fitting. So this is not good. Remote monitoring, these are pictures taken by myself. Here the full face mask is missing. This seal has to be replaced. Here full face mask is missing the valve. This one is not fitting properly. By the way, this is also a dangerous situation. He's standing here, the big bag. This should be avoided. Here the valves of the half face mask is gone. Here from the inside, here from the outside. So if you have these equipment, you should always check if they are intact. And because they are moved, they are stored improperly, they can be damaged, can be contaminated. So check before you start working and using these. By the way, this mask is actually very convenient, the half face masks. We often use them also. And here you see the color band, summary, respiratory protection, mask control, ingestion and inhalation of chemicals. There are many types of masks, selection of mask on hazard, dust, vapor and mist. Known all hazard of the compounds and the contamination, mask must be used and stored correctly. General rule: before starting the fieldwork, assess risk with a team in the start work analysis, select proper PPE, check the PPE, apply and control each other during work. Selection of PPE in season and climate, adapt working hours and time when conditions are severe. Use cooler packs can allow for better working conditions. Be aware that the use of respiratory may introduce risk. So here, this is Kyrgyzstan. I was above 30 degrees of Celsius. Here I was having a heat stroke. I did not pay attention, and here I was not controlling myself anymore. So it's very important to be aware of the risk that are introduced by using this very uncomfortable PPE, because you can get easily in stroke in warm conditions. Check and have your outside watch. General rules during work: stay alert for expected events during work. Demarcate, here we come, the zoning. Use pictograms on the fence. Stay organized. This is not organized. This is a mess. Remove after field work. Remove all PPE. Leave the PPE at the site. Disposables are chemical waste, personal cleaning, and do not bring the contaminants home. So this is wrong. Thank you very much. It was a long presentation and we left with one. Other questions on the personal protective equipment?
I don't see any hand, any comment.
So we have
I
half
think
an
the
hour.
last presentation is 1 hour, no, Mr. Fogg, more or less?
This one or the next one?
Yes, the last one, the module
It's
9.
Yeah, it's maybe, yeah, that's the last model.
Yes,
I can short it a bit.
little bit because we are behind schedule a little bit. If after they want to ask questions on this, so we keep some minutes on this.
Yeah, I'll try to be fast then.
Because the first day of the new year, we cannot be late.
No, okay. But this is a presentation on policy and legislation. I will skip then some slides and try to finish within a half an hour.